Smart picking with artificial intelligence and 3D vision. Today, we want to have a look on a little bit of a different way to a bin picking application, a little bit away from what's usually done in industrial bin picking, let's say. First of all, don't be afraid. I don't want to introduce IDS here in this case, but two major products come into point here. And this is, on the one hand, artificial intelligence on an edge device, which is our IDS NXT camera in this case, and a 3D stereo vision system, which is, as Miriam told us before, the Ensenso camera. Today, we want to combine those two technologies, those two products together, and let's see what can happen. So, to give you a short idea what we do today, first I would like to motivate and show you an application which we then solve and realize with this product combination. And last but not least, we come to a conclusion and to some practical examples where the things I will show you now are still used. So let's start. Let's imagine you're a shop owner and you have to refill shelves in your warehouse. If it's a small one, no topic. You go there, you fill them, and you're fine. But imagine you have really big warehouses, and you have to refill those shelves every evening, or even during the time when the people are inside. So wouldn't it be good to automate this process, to go ahead and say, okay, I have a robot which walks through my floors and then puts the items into the shelf back. A robot alone would not be enough at all, because you get those items normally in such unsorted boxes, and so it is hard to automate such kind of process because you have different items, different size, different material, different shapes, different behavior if you pick them. So that's not an easy task, and it's a little bit different to typical bin picking applications. So for such kind of applications, you first have to know what you pick, and then you pick it. So in this talk, we go deeper into this topic and see how we can realize this. Sorry. So the first step, as I told before, is to know what is in the box. If you think about a typical bin picking application, normally you know the items in your box. So you have single origin items, maximum 2 of them. So there is no need to specify before you pick what kind of item it is, because you know the object you pick. When it comes to warehouses or food logistic applications, we have to handle with applications, with natural applications, with goods with different size, different material, and even different behavior. I told before, think about a shirt, or what do you have all with us today, a pack of masks, and you pick them, and then they get a different size because your gripper or due to their weight, they get down. There is no stable surroundings like we would have when we pick metal or plastic parts. So you have to know what you pick. Your robot has to know what he's picking because he has to do. He has to go other ways. He has to be more flexible. He has to take care not to hit other things. For example, this may be an issue. So first thing, we have to know what we pick. If there are masks, if, as we see, noodles. This is a bottle, which has a total different behavior than a bag of crisps. Even your robot may need to change the gripper, because picking a bottle may work totally different to picking a bag of noodles. So due to this high variety of the objects, and even we don't talk about this, the environment around, the lighting condition, rule-based machine vision is not the first choice to solve such kind of applications. For such kind of applications, artificial intelligence is a much more appropriate solution. The same object may have different sizes. A banana doesn't look always the same, but you have to refill a banana. So we're here going with artificial intelligence. With artificial intelligence, we do not have to clearly, let's say rule-based, define the surroundings. We can learn and train the system to recognize what is inside of the basket, and also not only to classify, also to locate and detect where this item is, so that in the next step, your robot has a much more easier task to do. And to make this happen and easy for you, IDS develops the IDS NXT system. And with the IDS NXT Ocean, we deliver an all-in-one inference solution, including cameras which are able to use neural networks directly on the edge. So you can connect your camera and can let run an application there. But let run a neural network is one part of the story. The other part is how to train it, how to label the data. Also, on this case, we offer a cloud-based training service, which you can train the networks, which then later can run on the IDS NXT cameras. But step by step, we start with the hardware. I would like to give you a short introduction in the camera family we have at the moment. We have two major camera families. We have the IDS NXT Rio and the IDS NXT Roam. And for those people who know our IDS UI families, maybe they look a little bit familiar, because the IDS NXT Rio goes more the direction of the IDS UI SE camera, and the IDS NXT Roam follows the approach of the UI FA factory automation family. So from this point of view, from hardware point, you can expect similarity to those camera families, up to that the IDS NXT Roam supports IP65, 67. But for sure, that's not all. We included a web server on this camera, which allows us to communicate with the camera. We enabled the development of vision apps. So you as a user can develop your own vision app for the camera. We implemented a REST interface, which comes into the place when your camera has to communicate, for example, with your with robots or with your automation system. Once more, OPC UA, similar here, we have an industrial Ethernet protocol, which allows that a camera can directly communicate with the machines behind. So there is often now no need anymore for an integrated PC. But the real highlight on these cameras is our so-called deep ocean core. Maybe you heard the session last week from Professor Dr. Rastislav Struharic. He's one of the major inventor of the deep ocean core. If you missed it, doesn't matter. Have a look in the media library of the IDS NXT Vision channel. There, this talk is placed, and he explains in detail, but even understandably for me, one of the marketing team, how this deep ocean core works. So join the session. You can look them always on demand. So here we have a hardware accelerator for an FPGA. We go a little bit other approach than other camera manufacturers. We develop our CNNs on an FPGA. Here we can parallelize CNN operations. We have efficient memory management, and it's embedded. We have embedded on-camera optimization for the system, and this makes the IDS NXT camera family really specific and quite nice to handle such kind of applications we show now. As told, have a closer look on the session if you want to hear more about the deep ocean core. So this was the hardware part, IDS NXT Rio Rome, with hardware accelerator included. Let's have a short look on the software, because that's not all. We deliver with IDS NXT Ocean 2.0 also software possibilities. On the one hand, we have the classification and multi-classification. We have prepared apps for these tasks, so you do not have to develop them by your own. You just train your networks, you upload them to the IDS NXT camera, and that's it. Then classification and multi-classification will do. What is a differentiation between those? In classification, we have the complete image or only one ROI where we do classification. If we have multi-classification, we have different area of interest as much as you need for your application. And then we classify inside of this fixed positions area of interest. If you want to dig deeper into this topic, the next week we will also have sessions here where we go deeper into the topic how to use the classification and the object detection of IDS NXT, because this is the second part, or the second neural network application we have directly on the camera. This is object detection. Here you can detect the objects on unknown positions. That's the differentiation to the multi-ROI. There you have to define the positions. Here you detect the object on different positions, even they can move slightly. They can be on a conveyor belt, and you will always have the surrounding box and the class of the object. So with this information, you can then, for example, sort these objects, count these objects. And if you're not in a bin or a basket where it goes into the deep, so you're on a conveyor belt, for example, with this information, you could just start picking, because you know the coordinates of the object, and due to the conveyor belt, you know your height. But here we have a little bit of different application, as told before. We have bins, we have basket, where it's not only enough to know the location by a surrounding box and to know what is inside the box. We really have to know also the 3D coordinates to be able to pick. So object detection, this is what we need in this case, that we know, because we do not know up front where the items are inside of this basket or this bags. they're inside, and we have to identify the location and what kind of object this is. All these features surely also supported with IDS NXT Lighthouse. That's what I called just before the training service, our web-based AI training platform. So there's all the specialist knowledge included. So you as a user of the systems, you do not know how CNNs really will work. You label your images, you upload them to the IDS NXT Lighthouse training platform, and you get your neural network back, upload it to the camera, and let it run. For sure, there's a bit more inside. You get values, how good your net is. You can check this online, but in general, this is the process. Label your images, train the network, and then load it to the camera and let the AI run. So shortly again back to here. With all these methods, we have now an edge device with a trained network, and we can detect the objects in our basket. But that's not enough at all to grip them, because in this case, they are in a kind of 3D depth localized. So we have to localize them by 3D in the basket. It's not enough to only know a surrounding box. And therefore, as told before, we use our 2D, our Ensenso 3D active stereo vision camera. For those who are not familiar with this technology, I would give a pretty short idea of it. Also here we have a session in the Vision channel where Dr. Martin Hennemann, our product manager, describes the technology of 3D systems, also 3D active stereo vision systems into the deep. You can also find this in the media library. What happens with the Ensenso system? We have two cameras. So this, sorry. That's the stereo vision part. And we have a projector which projects a pattern on the area you want to see. And with this pattern projected, we get a really good 3D image, so really good 3D coordinates, even when there is low texture in the image. This is what wouldn't be feasible if you use passive stereo vision, for example. But as told, have a look at the media library. There is a session from Martin Hennemann, which goes much more deeper to this topic. The Ensenso can acquire images in one shot, or they can also placed inline on conveyor belts. There are two major series, let's say, of the Ensenso camera. We have on the one hand the Ensenso N series. These are small, compact, and lightweight cameras which can be placed on a robot. Think about our application we have. We would like to build a robot which goes to our store and picks and fills the shelves. So it is necessary to integrate a lightweight camera, a lightweight system, in this case, the Ensenso N. This camera can even be placed directly on the head of the robot. So this is the N series. And on the other hand, we have the Ensenso X series. With the X series is a much more modular system with a higher resolution. We can go up to distances up to 5 meters. With the XR system, we have even onboard processing directly on the 3D camera. This is quite necessary if you, for example, do a multi-camera setup because you reduce the workload of your PC. So taking the Ensenso 3D images and the object detection from the IDS NXT cameras, we are now able to clearly locate the items in the basket. We know the 3D coordinates, and we know what kind of item it is. So we know how we have to handle this item when we pick it. So we have all necessary parts together to solve this application, or one part is missing. We need a robot to pick. And here, for example, our cameras, the Ensenso camera is Techman robot plug-and-play certified, so you can directly connect the camera to the robot, to the robot's system and software, so you can directly use the 3D data. And our IDS NXT cameras are supporting OPC UA, for example, which allows also to directly connect the camera to the robot controller. Or depending on the controller, we also see more and more applications where REST or XML RIPC is used directly out of the camera and talk to the robot that there is no additional PC is needed. So now we have everything together. We have our AI cameras, we have a 3D camera, and we can connect them to a robot. We can solve the application. And till now, you saw only, let's say, images and examples. That we have here something which is real life. Still, we often we don't see it that often in real applications in warehouses, because a lot of them is under development still now. But a setup may look like this. So you have a robot, there is a box inside of it, and if you have a closer look to the system, there is a 2D camera, this an IDS NXT system and the Ensenso, which then picks the items either out of the shelf and put it into the box, could go also the other way, or pick it out of the box and bring it into your shelf. So I hope the last minutes I could show you that when we combine two different technologies together, in our case AI with the IDS NXT and 3D vision with the Ensenso, we can come to completely new solutions. And with this combination, you're perfectly prepared for today's and tomorrow's picking task.